Okay, let's look at a few problems from 5.3. It's 21 says you got 2 times 10 cubed squared, and they want to know if it's equal to, less than, greater than, whatever, than this 5 times 10 to the fifth. So in order to do this, we really need to simplify on the left-hand side what's going on. Now, I want you to think about this. This is really 2 times 10 cubed squared, okay? I'm just going to keep copying the rest of this down. If you look at it that way, it makes it easy to see, just by rewriting it without that x for the multiply symbol, that I'm supposed to square the 2. Now, 2 squared would be 4. And then I'm supposed to get 10 cubed. I've also got to square it. Well, 3 times 2 is 6, so that's 10 to the 6th power, okay? Now, what is 4 times, I can put the multiply symbol back in if I wanted to now, 4 times 10 to the 6th power, that would be a 4 with 1, 2, 3, 4, 5, 6 zeros after it. That's 4 million. Now this 5 times 10 to the 5 would be a 5 with 1, 2, 3, 4, 5 zeros after it. That's 500,000. So the answer would be greater than, wouldn't it? All right. I think the easiest way to deal with these is to change them into just decimal form so that we can really look at them. 0.005 squared, we know that 0.005 times 0.005 is basically going to be 5 times 5 is 25, but there's 6 decimal places to this. So I'm going to start here and move to the left 1, 2, 3, 4, 5, 6 and put my decimal place. And I'll fill in each one of those bumps with a 0. So over here, this is 0.00025. Now 2 times 10 to the negative 8 would be 2, but we're going to move 8 spaces to the left. 1, 2, 3, 4, 5, 6, 7, 8. Oh man, should have left more room. Okay, I got 7 zeros out front. 1, 2, 3, 4, 5, 6, 7 zeros out front here, and only 4 out front here. That means that this number here is definitely bigger than the one on the right, isn't it? Because it's this other one is really teeny tiny on this right hand one on 23. We'll look at 29. All right, on 29, they want you to simplify this. It says, assuming that the factors are approximations, give answers in scientific notation with the same number of significant digits as the least accurate factor. Okay. So we got 8 times 10 to the 6th, then 2 times 10 to the negative 2 over 4 times 10 squared. Oops. Didn't mean to mark that out. That's actually the decimal, the fraction bar going there. Now what the deal is they want basically all what they're talking about with the significant digit thing is that these numbers are all whole numbers, right? 8, I meant to circle in red. They're given this part of the number with a 1-digit whole number. They're not going out any decimal places. So we're not gonna go out any decimal places with our answer, in other words. If you look at this problem is really this. This is, if I wanted to, I could rearrange it and I could leave out the x for the times symbol, the multiply symbol, and write it like this. Okay, and then you got 4, and then you got 10 squared. All I'm doing is taking out the little x symbol that means multiply. Well, if you do that, you can kind of see what to put together. On the top, you could say 8 times 2 is 16 over this 4. Well, that's going to simplify to 4, isn't it, on top? Okay. Now, all the other stuff is powers of 10. And if I look at the top, and I'll circle in blue, 10, it's times 10 to the 6 plus negative 2 would be 4. But then I've got 4, and then on the bottom I've got 10 squared. Now if I take it one more step out, I've got 10 to the 4th over 10 squared. If I subtract the exponents, 4 minus 2 would be 2, and it would be on the top. This is just 4 times 10 squared, which is 400, but they're actually just writing it as 4 times 10 squared. That's all they wanted you to do. So when you see stuff that looks this weird, remember that you can take the multiply sign out, and then it makes it really easy because you've got all these bases of 10 with the same exponent, so we can just combine the exponent using exponent rules, and then multiply the other numbers out the way we did here. It turned out to be a pretty easy problem. I didn't even have to get my calculator out. Let's look at number 31. 31 is similar. This time I noticed they're giving me 8.4 times 10 to the 15th. They're going out 1 decimal place. And then I've got 1.5 times 10 to the negative 5. And then there's my fraction bar. And then 4.0 times 10 to the 4th. And 1.2 times 10 cubed. Now here I really might want my calculator for just one little thing. And here's what I'm thinking. Let me rewrite this first, I guess, without the x's for multiplication. This is the same problem as what I've got written above. If I do that, if I take the x's out, all of a sudden I can see that I've got two things going on. I've got some things that are numbers, and I've got some things that are powers of 10. Okay, that's a 3. We'll have to remember that. Now what I can do is this. Let me use some color here. I can say what's 8.4 times 1.5. Let me do that in my calculator. That's why I got my calculator out. On top that's giving me 12.6. Let me do the numbers on the bottom. 4 times 1.2 is 4.8. Okay, so I took care of all the number parts. Now I'm just going to go ahead and simplify that. And I'm just going to use my calculator. What's 12.6 divided by 4.8? It is 2.625. Now that's more accuracy than I'm going to have to give in a minute, but just for now I'm going to leave it like that, okay? Now let's take care of the part that are exponents of 10. I've got this term and this term. So it's times 10 on the top, and I'm going to add the exponents because I'm multiplying 10 to the 15th times 10 to the negative 5. Well, what? So we add the exponents. That's what the law of exponents says to do. 15 plus negative 5 is the same thing as 15 minus 5, which is 10. And let's do the same thing on the bottom. I've got 10 to the 4 and 10 cubed. If I multiply that, 10 times 4, 10 to the 4th power times 10 to the 3rd power, if I add the 4 plus 3, it would be 10 to the 7th. Now, I've already done the red part. On the green, the powers of 10, I could just say, okay, well, I've got a 10 on the top and a 7 on the bottom as my exponents. I can just say, what's 10 minus 7? It is 3. Now, they only wanted the answer with the same number of significant digits as the least accurate factor. So here's what they're saying. All of these up here, I'll circle in yellow, just went out 1 decimal place, didn't they? So we're going to go out 1 decimal place. So would 2.625, would it stay 2.6, or would it round up to 2.7? This 2 is not going to bump that up, is it? It's just going to be 2.6 times 10 cubed. That's what they wanted you to do there, was just give your answer with that kind. That's called significant figures when you look to see basically what kind of, how many decimal places are they giving you the information in. And so we're going to go out that many also. And so that's 31.